welcome. Thank you for having me. I'm here to talk about Cisco XDR, specifically the detection analytics and the Gen AI piece. And so I know that a lot of people like to talk. So I'm just going to say, go ahead and just say I said AI right out of the gate. So that's been an award for me. I'll also put it right in the title of the thing. There you go. So you guys can all pick on me for identifying that out of the gate. All right. This particular session, I'm going to walk through what is Cisco XDR, the data analytics and the pipeline in it, and then ultimately correlated incident. The longer I talk with slides is the less time I do a demo, so hopefully I don't talk that much and we can actually get over to looking at the product. It's much more interesting that way. So from the beginning, what is Cisco XDR? Cisco XDR is a collector of data from multiple security, in brackets, tools, where we apply analytics to that data to arrive at a detection of maliciousness and then provide response to that maliciousness through automated actions. It is, fundamentally speaking, it is a efficiency tool for the Security Operations Center. It is about accelerating that OODA loop, allowing a security analyst to make an observation, orientate themselves, make a decision, take an action faster than they would have done without said tool. It's an official objective, as we built the product out, is to make every tier 1 as effective as a tier 2. Now, fundamentally speaking, when we look at what it is because it is a collector and aggregator of data, or a collector and analyzer of data, integrations make XDR possible. No integrations, it does nothing. Otherwise it's just a dashboard, which literally does absolutely nothing. All value is achieved from integrations. I have broken down the integrations into 4 major surfaces. The first is data analytics and correlation. This is the biggest, hardest, most involved of the integrations, in the sense that we are going to take data in, put it into a data warehouse. We run analytics on top of it to arrive at those detections. This is the comprehensive integration, and which is the one that I'm going to talk through mostly about how the data analytics path works. The other 3 we can break down based on outcomes that we expect of them. So the bottom one here, asset insight and context. It's about integrating with things to get inventory information, so identifying assets. So integration surfaces like Cisco Secure Endpoint, Defender, CrowdStrike, etc., all have inside of them asset inventory. Meraki Systems Manager is another good example that has an asset inventory, where we can pull the asset inventory in and use that to define our assets. Threat hunting investigation is a surface level API integration with things that have data. So during investigation time, during a what I call enrichment, when we're building an incident, ask other integrated products what they know about these observables in our incident store. Things like, tell me what you know about this IP address, tell me what you know about this host name, and we bring that data back and we put it in the incident itself, or at investigation, which is display time. And then the bottom one here is automating and response. So this is integrating with other products to drive response actions back into the network or to the environment that we are deployed in. Okay, so the main thing I'm going to talk about is the data analytics and detection path. Where do we get incidents from? The main component of XDR, as I previously mentioned, is to take data in, provide analytics to arrive at a detection. An incident, in the XDR terminology, is a data object that is made up of data from multiple security tools, largely, or multiple integrated tool sets. As all of the data comes in, we do analytics, correlation, we create a logical incident bundle, which then is basically the object upon which an analyst is going to interact. And I'm going to largely, hopefully, demo this, as opposed to just describe what it is. Where does it create? How does an incident get created? It goes through a long, complex analytics pipeline in order to get to an incident. So to get to an incident, basically we start with data acquisition. That's the box on the far left. And then an analytics stack, which is our larger box on the right. So data acquisition, we integrate with a variety of different sources of data across several different domains. This includes different EDRs. We have native network telemetry. We have data coming in from integrated hosted infrastructure, AWS, GCP, and Azure are good examples. Data from the Identity Services Engine, and a handful of more different domains. Email, which includes email threat defense and Proofpoint as data sources that can come in and get analyzed. So what we do with all of those, so depending on the data source, some are APIs, some are streaming data, comes in, data is normalized, it goes into the data warehouse. Data warehouse is then basically where we run our analytics. The analytics stack goes through what I call an observation to alert model. Observations are algorithms that are running to look for certain things of interest in the data sets. We make an observation. Observations move to an alert on a probability-driven model. I call it probability A given B, which is Bayesian theorem. It's probability that this is an alert in the environment that we are in. Once you are created that alert, alerts then go through the incident correlation or correlated incident generation process. Before I get into that process, I just need to call out, we have what we have as native versus extended detections. Native detections in the realm of XDR are ones that we invent, or ones that we actually create a verdict. So for example, if you send NetFlow into Cisco XDR, we are going to use that to power several behavioral models. The behavioral models will go through that observation to an alert stage, generate an alert. That is a native detection, one in which we have created a verdict. We will say something like, this is a potential malicious activity, and assign a MITRE tactic and technique to the detection that we have made. So this is where we go from, that is a native detection, creating it from the data sets that we have. The native detections tend to fall through that probability model. We tune that probability model towards a high fidelity, low noise scenario. High fidelity, low noise, fidelity and noise are of course subjective. When we create a system that is that observation to alert model with high fidelity, low noise, it is important to note what that means, which is that alerts have passed the threshold for active notification. Being actively notified means, at a high fidelity, low noise way, means that not potentially every situation that is malicious actually passes that threshold. That's what the data is there. It resides in the database. You can search for it. You can try to find it. But generally speaking, alerting is at a high fidelity, low noise. Extended detection, on the other hand, extended detection is when we start with a data set that comes from an integrated product. EDRs are really good examples of that, where the data has a verdict in it. EDRs create detections. Detections have MITRE tactic and technique mappings. You have a verdict already that you can anchor off of, and then that becomes part of that is an extended detection, or things that we begin to extend by correlating other data on top of it. So native is verdicts we invent, extended is verdicts that come in from downstream. One of the common questions that I get is, what does an integration get me? I've mentioned that we have integrations across a variety of domains. Integration, like if I send Cisco NVM into Cisco XDR, what does that do for me? We've been recently introduced the MITRE attack coverage map, which I will demonstrate hopefully, which will help you to actually understand what an integration gets you in terms of MITRE tactic and technique coverage in your environment. Okay, so correlated incident generation. So far what I've talked about is data path in the sense of basically creating what we'll call an alert. An alert is a singular, sometimes aggregated or notification of similar data. So it's basically an alert that says, so for, let's say we integrate with a endpoint product, such as Cisco Secure Endpoint. Cisco Secure Endpoint makes detections on a host. Those detections pass up, and let's say all of the detections, let's say you have a piece of malware that runs several times, you can actually observe that malware and its execution several different times. We'll aggregate that into a single alert. We'll say suspicious endpoint findings by persistence is a very common tactic. We're aggregating it up at that tactic level, and then that alert shows up in the console. Correlated incidents is about taking multiple alerts and bringing and reconstructing the attack chain, or the attack lifecycle, or the progression of that attack in the environment. So the correlation analytics attempts to take multiple alerts or multiple independent alerts across those different domains aggregate them together into a logical attack timeline. I'm going to drill this or break this green box down a little bit more in the next slide. Once you have the correlation analysis that says these alerts are related and we have a attack chain that is built, we then summarize that using generative AI, which will put a natural language descriptor on what has happened in this multi-stage attack or incident that has occurred in the environment. Once that is done, we then promote the incident into the UI so that it is visible to the user. Before that, it was just software constructs in the engine, promote it up into the UI. In the UI, it is then, or once it's in the UI, it is then risk scored. So the risk scoring algorithms continue to change as the incident may or may not gain additional data into it. An incident is never complete until you mark it as complete. It actually can continue to have more data be put into it as the detection and analytics identify more alerts. And so the risk scoring, which I'll break down in a couple slides, this is about getting basically a prioritization queue in the incident, in the UI. And then final actions or final piece there is information enrichment. So the incident bundle, I mentioned that's data that has gone through the analytics stack. We have created the incident. We have all of the data that went through that front end of the system. Enrichment is just asking integrated products via API, what else can you tell me that is related to this incident? That data is then decorated on top of the logical incident bundle. Breaking down correlation momentarily. Correlation is about reconstructing the attack timeline. Attack timeline, which we use MITRE ATT&CK is the lexicon on which we talk about the MITRE attack timeline. So there are 14 different MITRE tactics right now that describe an attack timeline or the actions an attacker will take from reconnaissance through to impact. What we are doing is basically building out that attack timeline by correlating alerts. The major things of which alerts are correlated upon today is related alerts and common entities, which we then try to build out that attack timeline. So usually it's like, say, the same host has multiple different alerts across the spectrum of the attack timeline, or that particular host has, say, lateral movement has occurred across to multiple hosts. We end up saying these alerts are related because there's been several different observations and alerts that have been generated across these several hosts in the environment. And then ultimately end up with high priority incidents basically being created in that incident view, as we were talking about. This is one little view of the attack chain, and I'll show this a little bit more in the UI, but I just like to reemphasize that we are reconstructing that attack timeline right now based on the entities involved. So entities are noun data that describes assets or objects that are connected to the network. Entity objects are things like IP addresses, host names, EDR identifiers. So in Cisco lexicon, that's things like the CMID, Cisco Managed Device Identifier. In the CrowdStrike or Defender, they also have a UUID variable that identifies an entity uniquely, which is really just the unique identification of the endpoint in the asset on its own. Once the attack chain is created, it is summarized in AI. The LLM that is generating this description is fantastic. I will actually show this in the UI because it's pretty good just to watch a attack that has spanned in some cases many months to actually get summarized in a very meaningful top-level description of the event. So the last thing I'm going to talk about before I switch over into a demo is incident scoring and prioritization. It is the last step in the generation of that incident. Scoring is a value between 1 and 1,000, where there are two major variables that influence that score. First is the detection risk, and the second is the asset value. The asset value by default is 10. I'll make a note about this in the next slide, I believe. Or no, actually I took it out. The asset value is default at 10. That is right now the only user configurable value that can actually influence the scoring. It's configured on the asset inventory or the asset page for an asset. Just set the value of it. Detection risk takes into account 3 different major variables, the MITRE tactics and techniques that are involved in the incident. There is a financial model behind this. There's the probability of financial loss given the MITRE tactics and techniques that are involved in this incident. This comes from disclosures through past breaches, meaning these MITRE tactics and techniques that were seen in past breaches have resulted in financial loss. So given that we can now actually identify that, which is basically the probability that in this particular incident that they would result in financial loss, as well as the number of MITRE tactics and techniques. The more MITRE and tactic techniques that are involved really means the further along the attack life cycle this particular threat is, or this incident, and the more likely that it is actually high severity. And then the final one is source severity. Sources are the downstream sources that have past verdicts up, often have a severity associated with them. And that severity can further passes through into the prioritization score.
The assets, are those just devices, or does that include users as well?
Today, it's predominantly devices. Users are actually being incorporated into the system right now as we talk about what we have as Cisco's identity intelligence framework, which we launched earlier this year as we start to work that in as a data source into the product.
So being able to like classify,
yeah,
like
classify it
levels as a higher priority or a higher asset score.
That's right. Yeah. Okay, and the final thing in this, the AI SOC assistant will pop up as soon as I begin the demo. Relatively new to the product. Actually, it was still in a beta, I believe. We launched it at RSA conference a couple weeks ago, or announced it, and we've been demoing it. It's the AI SOC assistant, which is helping to guide an analyst through the response of an incident. We find it to be incredibly useful just to actually basically help guide and train an analyst and give them suggestions on what they should do next given the current state of the incident. Okay, so with that, I'm going to switch to demo. Okay, so first thing that I'm going to do is actually start not in XDR. I'm going to start in Meraki just for fun. So here I am in Meraki dashboard. One of the things we announced this week is an integration between XDR and Meraki. And what is actually happening here is this particular integration has allows all of those XDR incidents that I've talked to actually be displayed in dashboard. I call this the SNOC, Security and Network Operations Centers combined. We are really excited about this integration, and where it's going to go is actually you can begin to work incidents, assign incidents, change their statuses here in the Meraki dashboard, and begin to actually look at some of the data associated with an incident. This particular incident has a lot of data, so it'll take a moment to load. And you can actually look at the incident and begin to actually investigate it and manage it in Meraki dashboard. So switching over to XDR here for a second. Switching over to this XDR tab. I have many different things open today. It's a very busy day. Here we are in in the incident view in XDR, and you'll notice that there are a lot of incidents that have shown up here. There is one here near the top that is assigned to me. It's new. I'm going to click immediately into it and start to drill down into it. By clicking on this, we use a system of what we call progressive disclosure that a analyst experiences as they work through data. Systems of progressive disclosure is disclosing data to an analyst as they ask for it, as opposed to vomiting all of the data at their face the moment they log into the console. We're going to give them information when they request it, as opposed to just give it to them when they don't want it. So we started here with a incident, a score of 1,000. 1,000 is bad. Escalating intrusion clusters via endpoint exploits and process misuse. We've opened this, it's spread out. As I mentioned, it is new, it's assigned to me. So as an analyst, I should probably do something about it. Scores here, you mouse over, you can see the top level MITRE tactics that are here, the title, the summary, and then the longer description here are generated by our AI. That is that relatively new feature that I was mentioning about summarizing an incident. We can actually see that this incident started on the 5th of April and ended on on the 11th of April for a total of about 6 days. The security alert chain indicated a series of suspicious and possible unauthorized activities within the company's network and environment. Multiple devices were involved, blah, 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 blah. This is the executive summary. The full description is a little bit longer. There's a lot more going on. We'll dig into that in a different screen just so we can read it. We can see the assets involved really quickly. And we're like, well, okay, score of 1,000. Looks like it was a big deal. We'll click on View Incident Detail, and it will pop us into the full detail of this particular incident. Now, the AI assistant has popped up, and it's starting to make recommendations to me. And you can actually see the incident is already assigned to users and is a new status. Do you want to edit the users and continue to do this? And actually, you know what? The first thing I'm going to do is I'm going to say, yes, this is a real incident. I'm going to confirm the incident. What happens here is the AI is making suggestions to me based on the current state of the incident and what it thinks is best to do next. And so it's going to execute a workflow. Workflows are, you can define them over here, and I'll break that down in a second. But right now it is executing what is the confirm incident workflow. It does take a moment to fully work because it is actually relatively involved. One of the things that it is doing, it is creating a WebEx Teams room to that for this incident and assigning the users that are involved or have been tagged to actually work on this incident to be in that side of that Teams room, as well as creating that full bundle and actually beginning what we'll call the work log for this incident. So I'm going to set that aside for a moment just so I can begin to review this incident with you. And here we are. We can actually see the incident. I'm going to actually expand this so you can see more of it because it's going to have a lot of data coming at you in a second. And so what has happened here is we actually we have a high level view of an incident where we've grouped all of the components involved, the processes, the devices, the endpoints, the IP addresses, the users that have been involved. And as we expand on these, we can actually just start looking at details. We can actually see things like the user Marple has executed these particular processes that are involved with these other assets. So the green lines are the relationships between the objects involved. We have the devices, the IP addresses, the users, the processes, and so on. And so we can begin to mouse over and look at our different executions or the different components and interactions that have occurred in this incident and how it has progressed through time. Remember, this is a top level. This is the current state of all of the component pieces of data. So we'll collapse this just for a second and we'll come back to it in a moment. We can actually look at the assets, the observables, the indicators, and all of the different components. I'm going to go really quick. Actually, I'm going to bring up the detailed description. This is the AI generated description of the timeline of events that have occurred on this particular incident, from when it started and all of the different individual alerts and data associated with them that are a component of this incident. So the incident began with the suspicious process path alert being triggered, two particular alerts actually involving these two different hosts. The suspicious process path alert, that's a network visibility module derived alarm, which a network visibility module has logged flow data off of an endpoint. That in particular, this alarm is, there is a process that is running in the Windows directory that shouldn't really be running there. So it's a suspicious process path that's doing things out of the Windows directory that is not a normal type network connection. The suspicious endpoint findings by defense evasion alarm. This is a data that has come, I believe it's either from Defender or CrowdStrike. I'd have to look at the sources in a moment to see which one actually provided this data. So we've begun to correlate data across not just network data, but also into endpoint data as well. And we can see persistence attempts as well as continued through times. We see more alarms. We can see that it consistently is revolving around these two different assets, Flint Win 10, Obsidian Win 10. And then finally, we see final execution of the type of attack that occurred with non-standard LDAP processes and the likelihood that there are unauthorized users attempting to steal credentials off of some of our, off of our domain controllers, as we have very suspicious LDAP connections occurring in this particular environment. Okay, so we have the AI summarized description of the event, and my workflow that I started is actually completed. So now I can actually go, oh, well, I personally just reviewed that while it was happening. I can actually see there's a lot of things. We're going to begin to actually respond to this incident. The first thing we're going to do is we're going to contain the file hashes that were involved. So I'll click that button. And what's happened is the AI has moved us over into the response tab. So I started in the overview tab. Detection tab, we would have drilled down more into some of the details that were behind that high level description. The response tab is now we're going to begin to respond to the incident. Response walks us through the SANS pickerel model. So identification, containment, eradication, recovery. We're going to begin to slowly work through that. So the product has guides here, just basically giving you descriptions on what you might want to do in this environment. The AI is walking you through all of these items based on the current state of the incident. It's noticing that there are hashes involved or assets involved, and it's going to suggest that we do that. So I click the contain file hashes, and what the AI has done is taken us down to the contain file hashes option. We have pulled that drawer out for the right. These are the file hashes that are known to be involved in the incidents. Do you want to contain them? We will check a couple of them off. We're going to say yes, we do. We will click execute. I've checked off the malicious ones, and if we click execute, it will execute a workflow. Behind the scenes, this is now executing the contained file hashes workflow, which comes built into with the product. The contained file hashes workflow will contain those file hashes on any integrated product that can contain file hashes. So that includes, like, say, suppose you had integrated 3 different endpoint systems, such as Cisco Secure Endpoint, Microsoft Defender, the CrowdStrike Falcon. It would block those file hashes on all 3. Okay, so now we're at the AI is now suggesting that we contain the URLs in this particular incident. So he'll move down to the next step here. Bring this drawer out. Let's contain these 2 unknown URLs. We'll execute that workflow. It'll block that workflow on any integrated product that we have a supported integration for that is able to contain URLs. Similarly, we're now about to identify vulnerabilities that are here. We'll make a note about the vulnerabilities that are on these particular assets. We'll execute that particular workflow. And we will contain the final assets that are involved, which will be Obsidian and this particular, we're not going to contain our domain controller. That would be really bad. And we will click execute, and we will execute on that. And so now you'll notice that we're getting different suggestions as the state of this incident continues to change. We're getting really closer to getting done. We're going to reset a couple of users' passwords. We'll do that. And we'll reset these 2 different user passwords, including the system user. That's not a good user to reset their password on. Final action is validate validate eradicated host and unquarantined assets. This is the unquarantined, or at this point, we would assume that you've gone on and actually done the validation on your own, but we will execute this workflow because given the state of this workflow, this is the last thing that's really involved in, or given the state of the incident, this is the last thing the AI is able to recommend to us. So we'll just unquarantine these particular assets, and we're basically reaching a end state. So the AI has no more recommendations given the state of this incident. We've done it all. It's just great. We've eradicated it all. And the final step is to flip over here to the end, and we'll generate a final report. Report takes a moment to generate, but the final step of this whole incident workflow is generating that full report. So all of the actions that have taken, the top level description, the long description, the incident summary, all of the assets involved, all of the SHAs, file hashes, everything except that we saw will be contained in this final report, as well as the work log that has occurred, and the actions associated with it. And this is the final executive report summary and the final action that is involved in the incident. And that's it. That is Cisco XDR in a nutshell in 30 minutes.
Can you flag those endpoints as needing additional confirmation?
Yes, absolutely.
Like the Active Directory or kind of web server?
I went very quickly through as the AI was suggesting it. The AI was skipping over. Many of these are actually are very involved workflows. So let's say you wanted to actually flag them. It's like you would add notes, you would add more content here. You wouldn't, most analysts would not just go click, 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 it's done. You could, you also, if you were like, I don't want to do the click, click through the AI, I want to do it automatically, you absolutely could schedule that. You can create triggers to just automatically execute these workflows when you see this asset, these hosts, this particular detection, automatically do these things.
My question would have been along the lines of like containment.
Yeah.
When you were containing actual like workstations, was that like executing a workflow that shut down a port or something like that?
It will call the APIs of integrated products that will contain those assets.
Okay.
So contain assets.
The firewall would block them from going out.
Right.
Okay.
Yeah.
Or
So
hierarchy across the whole stack, you can like add them to the blacklist. So they can enter a containment role, something like that.
yeah, depending on what the rules are. So like that built-in workflow, contain assets was really hitting the APIs of, actually, if I'm at negative time, but it's really contained. Yeah, you have questions. But it is containing the, if I just bring it up really quickly, contain XDR contain assets. It is basically just going to set and contain these variables against that target endpoint. Set the variables, and for each of the integrated things that are there, just go and contain that variable.
Depending on what you've got hooked into the XDR.
That's right. This one looks a little bit bigger than the contain assets. It just has more, just more execution of that one. This one, for example, actually executed a Python script that was just right here. So whatever your script had inside of it.
It'd be neat if you could do that though. If you could actually shut down, and then use a port that the thing's connected to, and just.
Yeah. So like there is several different integrations that you can pull in to execute individual workflows like that. Shut down a port, shut down, updated a L3 rule. Integration with the ICE will, do it, and have identity services engine initiate a change of authorization, right?
Okay, yeah.
So lots of different options. So really just you end up basically thinking through what is the workflows that work best for your environment.
If you're doing ICE and you're doing like .1x, you could actually effectively shut down the port that way.
Yes.